Alright, a very good afternoon to all of you. So I welcome you all on YouTube channel of Unacademy IIT-JAM Live. This is your educator and I'm teaching IIT-JAM Chemistry aspirants and IIT-JAM Biotechnology aspirants on Unacademy Plus platform. So in this particular class, we'll be analyzing the previous year trend, the questions coming from inorganic section. Okay, so we'll be taking some questions also and we'll solve those questions also, and we'll discuss the concept related to that particular question, right? And with this we'll be just analyzing the trend, that how questions are coming from inorganic part. But before that, if my voice is audible and you can see me properly, just write down in the comment section, so that without further waste of time, we can start off with today's session. So very good afternoon Lokesh, good afternoon Astha, good afternoon Ankur, Aditi. So just let me know in the comment section if my voice is audible. Is it audible? Can you hear me properly? Okay, just let me know. Great. Okay, so let's start off with today's session. So before taking some questions, let's see what is the analysis of previous year question paper. Okay, so in this particular session I'll specifically talk for inorganic, but I will tell you in general also that what should be your strategy for TIFR examination in this less number of days, how you should prepare for TIFR examination. Okay, so first of all, let's talk in general that what should be your strategy now, right? For these days, what should be your strategy? So what I have observed in the previous year question paper is the questions are simple, but you need to think, right? You need to think for getting to the correct answer. So basically your concepts should be good. Okay, and if I talk specifically for inorganic section, because I'll be taking inorganic in this particular session, so the questions coming from inorganic chemistry are very less if I compare to organic and physical. Okay, so if I give you exact numbers, so what I have observed in previous years, that minimum 2 questions are coming from inorganic section, right? And it can go to maximum of 4 questions, that's all. Okay, 2 to 4 questions are in general. This is the average number from inorganic chemistry that is coming in TIFR examination. Okay, so inorganic chemistry has least weightage if I compare physical chemistry and organic chemistry. Okay, so 2 to 4 questions are coming, and in these 2 to 4 questions also, majority number of questions, okay, major number of questions, if I give you the exact numbers, so if you have 4 questions from inorganic chemistry, 3 questions or 2 questions are directly coming from coordination and OMC. Okay, coordination and OMC, and it can even go to 4 questions also, right? So you have 100% weightage of coordination and OMC, or you have at least 80 to 90% weightage of coordination and OMC, right? So what I would recommend you for inorganic chemistry, do not revise other chapters now. Okay, if you want to revise inorganic chemistry, stick to coordination and organometallic chemistry. Okay, because major number of questions, or I should say you, it is also possible that all questions will come from coordination and organometallics. Okay, so these 2 chapters are the most important chapters for TIFR examination from inorganic section. Okay, so specifically for inorganic, do not waste a lot of your time in inorganic for TIFR. Just revise coordination and organometallic chemistry for TIFR examination. Okay, so this should be your outlook, this should be your way to just prepare for TIFR examination from inorganic section. Okay, so this is all about inorganic section, what I have observed in previous year question papers. And if I give you general general way of just preparing for TIFR examination now, so what you should do, yes, definitely PYQ solving is important. You should solve PYQ question papers, but I would recommend you, this is my personal this is actually I'm giving this particular suggestion, right? You if you like the suggestion, you can follow it. So what I have observed, or what should be your planning for TIFR examination is, just give 2 to 3 days before your examination to PYQs. Okay, this 2 to 3 days will be more than enough for PYQ solving. Okay, so just reserve 2 to 3 days before your examination for PYQ solving. And now what you can do, you can just select some major chapters, okay, from which your 80 to 90% syllabus is coming, and just revise those chapters, okay. If I give you exact number of chapters, so at max the chapters would be 5 to 7 or 5 to 8, right? So these chapters are very, very important for TIFR, okay. So if I tell you important chapters for TIFR, so that would be physical spectro, or in general let me write spectroscopy, because from organic spectroscopy also number of questions are coming, okay. So spectroscopy is one major chapter for TIFR examination. Then right, quantum is important, okay, quantum is important. Then thermodynamics is important, right? So these three chapters are very, very important for TIFR. Now if I tell you from inorganic, so coordination and OMC is important, right? Coordination and OMC is important. And if I tell you from organic, so from organic right now you don't have to study much, because you have studied enough for JAM, right? From JAM point of view, so that much knowledge is enough for your inorganic your organic session. But if you want to revise, you can revise reagents, okay, you can revise reagents, and organic spectroscopy will cover over here, right? So these chapters are very important. And if I tell you, these are major chapters that you need to cover for TIFR. If I tell you minor chapters, right, so after just revising these chapters, you can cover chemical kinetics, you can cover electro, right, you can cover electro, you can cover some part of gaseous state, right, because some questions are coming from gaseous state every year. So these three chapters are very important if I tell you minor chapters, okay. But in these chapters also you don't have to waste your time in complete chapters. You have to pick some specific topics from these chapters by analyzing previous year question papers, okay. So if you start solving previous year question paper, you'll definitely get the way that how you have to solve these particular right, previous year questions, and how you have to revise these particular chapters, okay. So you can, what you can do, you can just pick one question, right? Let's suppose you are starting from 2020 previous year question, right? So what you can do, you can start solving those questions, and if you think you are not getting the question or your concepts are not clear in that particular question, just go to your notes, revise that portion, and solve next chapter, okay. So this is the way you can actually prepare yourself for TIFR examination. And right, if I tell you what is more important rather than preparing, right, the mindset. You should prepare that in examination you have to give complete 3 hours, right, in a logical way, right. You don't have to just solve question for the need of solving the questions. You have to analyze each and every question, right, and you have to give best to each and every question, okay. Yes, electro and kinetics are also important, okay. So this is the trend analysis of previous year question papers. This much these chapters are right, these chapters are very important for majority of syllabus. Definitely we have some questions coming from minor chapters also, but first you have to give more focus to these chapters, okay. And for these chapters also specifically you have to start from specifically you have to study some some specific topics, okay. So this is all about this session. So as far as inorganic section is concerned, because I have to take inorganic section in this class, so for inorganic, coordination and OMC is enough. These two chapters are more than enough for inorganic chemistry, okay. So without further ado, let's take some previous year questions of inorganic chemistry, and you'll yourself get the way that how you have to study for inorganic chemistry, okay. So let's take very first question from inorganic chemistry, okay. So this is the first question. Answer is already given. You must be having question papers with answer key also. We'll figure out that how option D is the correct answer, why not A, B, C are the correct answers, okay. So let's start with very first question. So I'm giving you 30 seconds to read this question, then we'll definitely start off with the concepts of this question. Chemical bonding, see right now it's not possible for you to revise each and every chapter, so just stick to the major portion, right, and start solving previous year question. Chemical bonding is important definitely, but if you have studied chemical bonding for JAM point of view, so I don't think you again have to start studying it, okay. So 30 questions for you to just read this question, then we'll start off with this the solution. Let's see what the question is saying. Iron, cobalt, nickel are 3 known elements that display ferromagnetism, okay. Which of the following statement is true about ferromagnets, okay. So let's read first question. In the presence of magnetic field, the unpaired spins of a ferromagnet all align with the external field. This part is correct, okay. Definitely this much part is correct, Okay, next is then in the absence of external magnetic field, these spins then revert back immediately to their original state. So this part is correct or incorrect? Yes everyone, definitely this is incorrect statement. Okay, so they are permanently aligned. Okay, if I take spins of paramagnetic electrons, so even if I remove external magnetic field, the extent would be decreased, that is for sure, but they will align these unpaired electrons in one particular direction. They won't lose their paramagnetism, they won't lose their magnetism, right, if I take this magnetic field. Okay, so this statement is incorrect. These spins then revert back. No, they stick, right, they stick to their position, they stick to their direction, even if I change, even if I reduce, even if I take the external magnetic field. Okay, so they have permanent magnetism. Right, is it clear everybody that option A is definitely incorrect option? Right, I hope this point is clear to all of you. Let's go to the next option now. The origin of magnetism in a ferromagnetic arises from randomly arranged pair spins in a lattice. No, again it's an incorrect statement. They are aligned in one particular direction. Okay, they are aligned in one particular direction. Okay, please everyone concentrate over here, right, what I am trying to explain you. This will definitely help you in approaching the questions. Okay, so I hope you are getting the point that option B is definitely incorrect statement, because they are aligned in one particular direction. They are not in random motion. Okay, they are not in random motion. Random motion is observed in paramagnetic substances, right, not in ferromagnetic substances. Is it clear that option B is definitely incorrect option? Let's go to the third one. A ferromagnetic material is weaker in its attraction to external magnetic field than a paramagnetic material. No, ferromagnetic material is stronger than paramagnetic material. Okay, so ferromagnetic material is stronger than paramagnetic material. Is it clear everybody that option C is also incorrect? So correct answer would be option D. I hope you're getting the point that how option D is the correct answer and why A, B, C are incorrect options. Okay, great. Let's move on to the next question. How many normal modes than CS2 molecule have? How many of them can be observed using IR or infrared spectroscopy? Okay, now CS2, this is nothing but it's similar to your CO2. If you're confused, right, for CS2, then I think you must be having complete information for CO2, right? So just imagine this molecule as CO2, because the molecule and the structure is same. Just in place of oxygen, you have sulfurs over here, right? Okay, just in place of oxygen you have sulfurs over here. So how we can calculate total number of modes present, vibrational total number of modes? So this is a linear molecule, and for linear molecule 3n minus 5 is the way how we can calculate total modes of vibration. So n over here is 3, so 3 into 3 minus 5, 9 minus 5 will give you 4. That means you have 4 modes of vibration. So this one thing can cancel 3 options, that is A, B and D. So you have 4 modes, you have 4 normal modes of vibration, and how many of them can be observed during IR spectroscopy? So definitely you have one stretching frequency, you have one symmetric stretch, okay, you have one asymmetric stretch, you have one asymmetric stretch, and you have 2 bending vibrations. Okay, you have 2 bending vibrations. Okay, like this you have 2 bending vibrations, right? You have 2 bending vibrations like this. So what you can do, definitely, right, so this one is, you can observe this in IR spectroscopy, because you have dynamic dipole moment. For your IR spectroscopy you should have dynamic dipole moment. Okay, so in this case you have dynamic dipole moment, in this case also you have dynamic dipole moment, but in this case due to symmetrical stretching, this is not dynamic dipole moment. Overall dipole moment would be 0. If overall dipole moment is 0, so this won't give you a signal in IR spectroscopy. Great, this won't give you signal in IR spectroscopy, right? Symmetry will be inactive. Definitely this mode will be inactive, because this is going to give you right, this is going to give you no signal in IR spectroscopy. Okay, so we can say that definitely 3 will be observed. Or what can I say, there is one more term, right? You must have heard that term, that is role of mutual exclusion, right? Mutual exclusion principle. What is mutual exclusion principle? First of all, the condition for mutual exclusion principle is you should have center of symmetry. If you have center of symmetry in a molecule, so what we can say, IR active modes would be Raman inactive, right? And Raman active modes would be IR inactive, right? IR inactive. So we can say that this mode is IR inactive, so it must be Raman active mode. Great, it must be Raman active mode. So we have 4 vibration, right? We have 4 sets of vibration, or we have 4 modes of vibration, and out of those 4 modes of vibration, 3 would be IR active, 1 would be Raman active. Total will give you 4 modes of vibration. So correct answer would be option C. Clear everybody? Any doubts over here? I hope you can just understand this problem. Let's go to the next one. If in case you have any doubts, you can let me know in the comment section. Okay. So next question is, a complex of chromium plus 3 in aqueous hydrochloric acid was found to exist in 2 geometrical isomers. Okay, just break the question in 2 parts. Okay, this way you can get to the question more quickly. Okay, so what I'll be doing, I'll read the statement. I won't go right. I won't read the statement. Right, I won't go with the statement. First, I'll break the statement. Okay, the question is, a complex of chromium 3 positive and aqueous hydrochloric acid was found to exist in 2 geometrical isomers. Okay, definitely CO3 plus exists in 2 geometrical isomers. Okay, a white precipitate was formed on addition of equimolar amount of AgNO3. Okay, that means you must be having ionized Cl minus, or you must be having Cl minus out of complex where. Okay, so can I cancel option A? Definitely. Right, can I cancel option A because you don't have any Cl over here? So definitely this won't give you white PPT. This won't give you white PPT, so I can cancel out option A. Right, now we have to tell the structure of complex. Okay, so the chromium is present in +3 oxidation state, and it was found to exist in 2 GIs. Okay, so what can I say? See, over here we can cancel out option A because we don't have any Cl over here. Right, over here you have 2 Cl and 4 H2O, so cis and trans is possible. Right, cis and trans is possible. Over here no GI is possible. Can I say there is no GI because you have 5 H2O and 1 Cl, and over here also there is no GI. So geometrical isomerism is not possible in option D. It's not possible in option C. It is only possible in option B with 1 mole of Cl minus. That will give you AgCl precipitate. So correct answer over here would be option B. Clear everybody? Just let me know in the comment section if this is clear. I hope this one is also clear. Let's go to the next one now. Clear, right? I hope you can relate with the concepts of this question. Okay, let's go to the next question. Now what does this question says? In isoelectronic series, this and this. Okay, this is isoelectronic series. All members have intense charge transfer transition. The incorrect statement, you have to find the incorrect statement. Okay, charge transfer transition are attributed to excitations of electrons from ligand to metal. Okay, is it so? Let's confirm. So VO43 minus, CrO42 minus, MnO4 minus. Oxidation state +7, oxidation state +6, oxidation state over here it is +5. Okay, so if the metal is present in its highest oxidation state and you have pi donor ligands attached with the metal, so definitely which type of charge transfer spectra is possible? LMCT. LMCT is possible, ligand to metal charge transfer spectra. So definitely option A, charge transfer transitions for excitation of electrons from ligand to metal. This is correct statement, and you have to identify incorrect statement. Okay, next option is MnO4 minus exhibit charge transfer at shortest wavelength. Okay, let's see this. Now let's find out the relation for wavelength. If I take V5 positive, if I take Cr6 positive, if I take Mn7 positive, right? So which is having highest electronegativity? Now you guys have to tell me in the comment section which metal is having highest En value. I won't go to the next question before you guys answer me this question. Which of the metal is having actually highest electronegativity value? I'm waiting for your answer, so just let me know in the comment section that which metal will have highest electronegativity value out of V5 positive, Cr6 positive and Mn7 positive. Okay, great. Right, okay. So now I'm getting your comments. LUMO of Mn7 positive will be low lying among them. Okay. V5 positive. Shivangi is going with V5 positive. Palak is going with Mn7 positive. Then Rajendra is going with Mn. Alright, alright. Definitely. Okay. See, when I am going from left to right, so this would have, right, this would have highest electronegativity value. Okay, this would have highest electronegativity value. If you have highest electronegativity value, so according to molecular orbital theory, the ones which is having more En value will be low lying, right? The energy would decrease for more electronegative elements, metals or atoms. Okay, so definitely Mn7 positive is more electronegative negative than chromium 6 positive, which is more electronegative than vanadium 5 positive. So definitely Mn7 positive will be over here, somewhere over here. Cr6 positive will be over here, and V5 positive will be over here. So this is going to be your energy profile, right, orbitals of your metals. Okay, so definitely this is going to be your metal. Now you have O2 minus. Okay, now you have O2 minus, or you have oxide which is giving the electrons. Okay, if you have oxide which is giving the electrons, so definitely oxide is going to give from 2p orbital, right? It's going to give you from 2p orbital, right? So definitely 2p orbital will be low lying than your metal orbitals too. So this is how this will give electrons, right? Is it clear, everyone? Any doubts? Right, this is how this will give electrons. Okay, 2p to this Mn, 2p to chromium, 2p to vanadium. Okay, so you can see this is least energy, then this one, then this one. Okay, so this is ligand to metal charge transfer spectra. So if I want to arrange them in energy order, so Mn7 plus will have least energy, then chromium 6 plus, then you will have vanadium 5 plus. Okay, so this is the order of your energy. If this is the order of energy, so lambda order would be just reverse. Okay, so lambda 5 positive will have, right, a least wavelength, then chromium 6 positive, then Mn7 positive. That means Mn7 positive will have a right longest wavelength. Okay, so Mn4O4 minus exhibit charge transfer at shortest wavelength. No, this is absolutely incorrect statement. Okay, this is absolutely incorrect statement. Okay, so option A is definitely correct, option B is incorrect. Let's go to the third option. The wavelengths of transition increase in this order. Yes, you can see over here we have also written that this is Mn7 positive, Cr6 positive, Vr5 positive. So definitely option C is also correct. Okay, wavelength increases in this order. Okay, next is the charge on the metal nucleus increases in this order. Yes, you can see this is 5, this is plus 6, this is plus 7. So option D is also correct. So incorrect option over here is option B, which is MnO4 exhibit charge transfer at shortest wavelength amongst the three. Okay, so I hope this question is clear to all of you. Any doubts over here? Great. Okay, let's go to the next question now. This is your next question. Okay, next question is the clusters this and this have structure respectively. You have to find the structure of these three clusters. Okay, you have to find if they are closo, nido or arachno. Okay, let's start with SN5 2 negative. Let's start with SN5 2 negative. Okay, so how many valence electron in team? We have 4 valence electron. It belongs to carbon family. So 4 into 5 plus 2. Okay, 4 into 5 plus 2. This is how I can write this, this particular number of electrons. If I want to calculate total number of electrons, so can I write this this particular notation in 4n plus 2 form? Right, because n over here is number of metals. Okay, n over here is number of metals, so number of metals are 5 into 4 plus 2. Okay, so we can write in 4n plus 2. So when the electronic configuration count is 4n plus 2, so this is closo cluster. Okay, this is closo cluster. So definitely closo and closo. Okay, so option 1 is closo, or the compound 1 is closo. Okay, let's go to second compound, that is Ge94 negative. Okay, again it's from carbon family. So we have 4 into 9 plus 4. Okay, 9 over here is number of metals, so we can write down number of elements over here, not metal, number of element. So we can write down 4 into n, that is 4n plus 4. Okay, so 4n plus 4 will give you nido. right? 4n plus 4 will give you nido. So closo and nido, closo and nido. Let's go to the third one. Okay, so how we can calculate for third one? We have RH6 CO16. So we have to apply Wade's rule over here. Let's calculate total number of electrons. Okay, so total number of electrons would be 9 into 6 because rhodium is from cobalt family. So valence electrons would be 9. 9 into 6 plus 16 into 2 would be 32. So this will give you somewhere around 54 plus 32. This will give you 6 and 86. This will give you 86 electrons. Now you have to count polyelectron count. Okay, so how you can just count that number? So you can write down valence shell electrons minus 12n divided by 2. So this is 86, right? 12 into n over here is 6. Okay, 12 into 6 is 72 divided by 2. Okay, so this will give you some value around 14 divided by 2. So that is going to be 7. Okay, so how we can write down 7? How many metals do we have? We have 6 metals. Okay, so we can write 7 as 6 plus 1. So this is nothing but n plus 1, and n plus 1 will give you closo. N plus 1 will give you closo. So option B is going to be correct option. Clear everyone? Any doubts? Just let me know in the comment section if this question is clear. Okay, so that we can take the next one. I hope this point is clear to all of you, that how we have to calculate the geometry of this particular clusters. Okay, of these clusters. Clear everyone? Great. Okay, so let's take the next question now. Great. Okay, so let's take the next question, and the next question is, which of the following is incorrect? Okay, which of the following is incorrect statement? Okay, let's start with option D. Okay, let's start with option D. Acidity of the following oxyacids in water: HIO, HIO2, HIO3, HIO4. Definitely the oxidation state over here. Calculate oxidation state over here, and over here. This is plus 7, right? This is plus 5. Great. This is how much? Plus 3. This is plus 1. Okay, so if you have a same metal over here and oxidation state is increasing, so definitely the acidity will also increase. Acidity will also increase in this way. So option D is going to be correct. Acidity of following oxoacids in water is HIO, HIO2, HIO3 and HIO4. Okay, so this is absolutely correct statement. Okay, let's start with option C now. In option C, right, we have to find if these two structures are tautomers or not. Okay, definitely they are. If this oxygen is having lone pair of electrons, this will go over here. This double bond will migrate over here. This double bond will go over here, and there is going to be a negative charge on this carbon. Okay, so what's going to happen? We will get something like this, double bond OH positive, and this double bond will go over here. Then we have a fused ring over here. This double bond will go over here and a negative charge. Okay, so what's going to happen? This H plus will leave, and this negative charge will take this particular H plus ion. Okay, so you'll be having double bond O over here, a double bond over here, double bond over here, and positive. Okay, so this is how it's going to be formed. So definitely they are tautomers. Alright, they are not resonating structures, because you can see there's addition of this OH bond which is not present over here. So these are not resonating structures, these are tautomers. Okay, so these are tautomers, nothing, right? You have to just take the alpha hydrogen over here. Alpha hydrogen will go over here, and O minus will abstract alpha hydrogen. Okay, so you'll be having something like this. Okay, so this is nothing but tautomers. Okay, so option C is absolutely correct. Option C is absolutely correct, right? I hope you got this question right. Option D is correct, option C is correct. Now you have to figure out option B. Okay, which is going to be more acidic, right? Okay, which is going to be more acidic? This is going to be more acidic, or this one. Okay, so if I take negative from here, we'll get something like this. Okay, a benzene ring over here, a phenyl ring over here, a 5-membered ring, and this particular value like this. Okay, and a benzene ring over here like this. Okay, so now what you can understand over here, there is negative charge over here. Now if there is negative charge, so what you have to understand, what is the role of aromaticity over here, right? Due to this negative charge present, this negative charge is delocalized with this phenyl ring, it is delocalized with this phenyl ring, it is delocalized with this phenyl ring. Okay, so there is loss of aromaticity of one benzene ring, loss of aromaticity, right, of phenyl or benzene ring. Okay, if there is loss of aromaticity of phenyl or benzene link, so this effect is known as annulation effect. Right, this effect is known as annulation effect, that there is loss of this benzene ring aromaticity due to presence of alpha negative charge. When this is the factor, due to presence of alpha negative charge, this effect is known as annulation effect, because this benzene ring is sharing some of its electron density with this particular negative charge. Okay, so this will decrease the electron density on the benzene ring, or this will lose the aromaticity of your benzene ring. Okay, so this is going to be more acidic, because this compound is now going to be aromatic. Okay, this is not aromatic, this is non-aromatic. After losing one H plus ion, this will become aromatic. So definitely what's going to happen, this will be more acidic than this one. Clear everyone? Any doubts? Now let's go to the first option. Okay, first option is this is less acidic than this one. So whenever we have to compare Ka or acidity for transition metal complexes, how we can compare it? First is transition metals are always more acidic than non-transition metals. This is the first point. Transition metals are always more acidic than non-transition metals. And second point is, right, +3 or high oxidation state, right, is more acidic than low oxidation state. Clear everybody? High oxidation state is more acidic than low oxidation state. Okay, so everything is same over here. You have 6 aqua ligands, right? You have iron over here. What is different? Oxidation state. Fe3 plus, Fe2 plus. Okay, so which is going to be more acidic? Definitely Fe3 plus is going to be more acidic, right? High oxidation state is more acidic than low oxidation state. Okay, so option A is going to be incorrect. Clear everyone? Any doubts to anyone? I hope this question is also clear. Let me know if you have any doubts in this question. Clear everybody? Okay, great. So this point is also clear to all of you. Let's go to the next one now. Okay, let's take next question. So what is the product of the following reaction? Okay, so what we have square planar complex. Okay, what we have square planar complex. Okay, so if we have square planar complex and we are adding NO ligand to this particular complex. Okay, so let's see the options. This would be, now this is a square planar, it is going to octahedral, square planar to octahedral. Okay, see these two options we can definitely cancel out, because if I calculate the CFSE value of square planar, so that is much higher than CFSE value of your octahedral compounds. Okay, so this is not going to be a stable reaction, this is not going to be a kinetic reaction, so we can say that definitely these two options we can cancel out. Okay, now over here you can see 3 ligands are attached, and over here 2 ligands are attached. Okay, so how, let's suppose we are attaching this first ligand. Okay, let's suppose in place of this SPH we are attaching NO over here, right? So this is having more trans effect than this ligand. Okay, so this type of substitution is not possible, right? This type of substitution is not possible, because you have to attach over here, right? Because this is also elimination is also possible, and this elimination is also possible. Okay, so what is going to be your correct answer? Option A is going to be your correct answer due to trans effect. Okay, trans effect, which is a kinetic effect. So due to trans effect, we can say that option A is going to be your correct answer, right? So see, the question is very simple, you just need to figure out the correct approach. Okay, so let's take the next question. This is your next question, and the question says the Haber process is commonly known as the reaction of hydrogen gas, okay, definitely, plus nitrogen gas to produce ammonia, right? In the presence of catalyst, right, that is iron. So in the presence of catalyst, that is iron. Okay, which of the following statement is true regarding the Haber's process? Iron serves as a homogeneous catalyst for this reaction. Now what is homogeneous catalyst and what is heterogeneous catalyst over here, right? What is homogeneous catalyst and what are heterogeneous catalyst? Okay, so see, homogeneous catalysts are those catalysts which is in same phase as that of your reactants. Okay, so let's take this example only. We have H2 in gaseous medium, we have N2 in gaseous medium, and iron over here is present in solid phase. Okay, it is present in form of magnetite, which is ore of iron. Okay, so iron is in solid phase and H2 is in gaseous phase, nitrogen is in gaseous phase. So this catalyst is not homogeneous catalyst, this is heterogeneous catalyst, right? Iron is heterogeneous catalyst. Okay, if you are not clear with homogeneous or heterogeneous, what you can do for this question, see, you know that H2 is present in gaseous state, nitrogen is also present in gaseous state, and we know iron, this form in which iron exists is solid. Okay, so iron is a solid, H2 is gas, nitrogen is gas. So these are not homogeneous catalyst, this is a heterogeneous catalyst. So option A is definitely incorrect. Okay, option A is definitely incorrect. Okay, next is increasing the temperature increases the amount of ammonia formed. Is it so? Right, this type of reaction is exothermic or endothermic? Yes, everybody, comment down in the comment section. This type of reaction is exothermic or endothermic? What do you think? Right, this is exothermic reaction. Okay, because you have one hydrogen bond, you have nitrogen bond, and you are forming hydrogen bond. So this type of bond has more thermodynamic stability than hydrogen and nitrogen bond. Okay, so yes, more strong bond is forming, so definitely this is exothermic reaction. If this is exothermic reaction, so if I increase temperature, so exothermic reaction means you have heat in the product side. If I increase temperature, so the reaction will shift to backward direction, and if the reaction shifts to backward direction, this means, right, that you are decreasing the concentration of ammonia produced. Okay, you are not forming more amount of ammonia, even you are decreasing the concentration of ammonia. Okay, so increasing the temperature increases the amount of ammonia formed? No, it would decrease the amount of ammonia formed. Okay, so option B is absolutely incorrect statement. Okay, option B is absolutely incorrect statement. Okay, next is pressure. Okay, now H2 gas plus N2 gas gives you 2NH3. Okay, gas. So how you can just balance this equation? This is 3H2 gas plus 1 N2 gas will give you 2NH3. Okay, now we have to deal with pressure. So whenever we have to check which is going to be the reaction, if I increase or decrease temperature or pressure, for pressure specifically I have to calculate delta Ng. Okay, so what is delta Ng over here? 2 for NH3 minus 4. Okay, so delta Ng over here is minus 2. That means you have more number of moles in product side, reactant side, not product, in reactant side you have more number of moles in reactant side. Okay, so increasing the pressure increases the amount of ammonia formed. If I increase the pressure, the reaction is going to shift in that direction where you have less number of moles. Okay, so you have less number of moles in product side. If you have less number of moles in product side, so definitely on increasing the pressure, the reaction will shift to forward direction. Okay, the reaction will shift to forward direction. So this statement is absolutely correct. Okay, so this statement is absolutely correct. So option C is going to be a correct answer. Okay, I hope this is also clear. If you're not clear with the technicality of your Haber's process, still you can do this question. Okay, this is all about the concepts of your chemical equilibrium. Okay, let's take the next question now. Right, clear? So identify the high spin complex. We have to identify the high spin complex. Cobalt 3 positive, cobalt 3 positive, cobalt 3 positive, D6, D6, D6. Right, in 3 positive, ammonia is a strong free ligand. So this is going to be your T2G set. Cn negative is a strong free ligand. This is going to be your T2G set. Why I am going too fast? Because I hope you know these concepts now. I don't want to start from basics. This will unnecessarily waste your time. Okay, and I don't want to waste your time. I'm just over here, so that I can tell you that what is the correct way of approaching the question or how you can approach this question. Okay, so I hope you can understand that why I'm going too fast over here. If you think you're having any doubts in between, you can stop me over there and you can let me know in the comment section. Okay, I'll explain you from the basics. So this is D6, 1 2 3 4 5 6. Okay, cobalt 3 positive, F negative is not strong field ligand, it is weak field ligand. Okay, so if F negative is weak field ligand, so this is going to be your T2G set 1 2 3 4 5 6, right? So you can see you have unpaired electrons over here, and right, there is no need of pairing over here. So this is high spin complex. Okay, there is no need of pairing over here, so this is high spin complex. Okay, so option C is going to be your correct answer. Okay, option C is going to be your correct answer. Is it clear, everybody? Any doubts? Clear? Great. Let's go to the next question now. Predict the relative rates for the following reductive elimination of X hydrogen chlorine CH3 and OCH3. Okay, now you can see you have platinum in 2 oxidation state, right, and you have platinum in 0 oxidation state over here, and the elimination of CH4. Great, there's an elimination of CH4, and you have platinum in 2, you have platinum in 0 oxidation state. Okay, and this is your ligand, that is phosphorus, which is attached with this right ring over here. That means it's something like PPH3, right, or we can say it's something like PPH3 with X as substituent at para position. So this type of ligand is pi acceptor ligand. Can I say this ligand is pi acceptor ligand? Right, PPH3 type of ligands are pi acceptor ligand, right? Okay, pi acceptor ligand. Okay, more electron will stabilize the product. See, now what you have to see over here, when you have 2 positive, you are going to 0. Okay, if you are going to 0, so that means you are increasing electron density on metal. You are increasing electron density on metal. So that means what should be your outlook? You can think, right, with 2 ways. First way is you should eliminate a more electron rich leaving group, right? You should eliminate more electron rich leaving group so that you can balance this negative charge on metal. This is first way of approaching this question. Or the second way is, right, now you should have more pi acceptor ligands, right, in product. You should have more pi acceptor ligands in product. Over here ligands are same, LL and L2. That means you don't have to see pi acceptor tendency of your spectator ligands. What you have to consider over here? You have to consider your these 2 ligands. Okay, you have to consider these 2 ligands. Okay, so let's suppose you have CH3 over here and H. So what we are doing? We are doing reductive elimination. So reductive elimination depends on 2 factors. It is directly proportional to electron rich leaving groups. Can I say it's directly proportional to electron rich leaving groups, and it's directly proportional to steric hindrance? Can I say this thing? It's directly proportional to electron rich leaving group, and it's directly proportional to steric hindrance. Okay, so this is how we can think of this particular concept. So if I see these all if I see these all ligands, so let's see what is going to be the nature of these leaving group. Okay, so Cl minus is a pi donor leaving group. Yes, everyone, do you agree with this statement? Cl minus is a pi donor ligand, right, and all these ligands we can say, right, it is basically having a kind of a pi donation. Okay, this is having a pi donor ligand, this is also pi donor ligand. What about CH3 negative? Is it a pi donor ligand? What do you think? Just let me know in the comment section. CH3 negative is a pi donor ligand or something else? CH3 negative is pi donor, pi acceptor or sigma donor? Right, okay, these groups are attached to pH rings. Okay, so what we have to see over here, we have to see that which of the following group, right, is acting as pi donor, sigma donor, or your pi acceptor ligands. Okay, so let's suppose this, definitely they are attached with pH, right? So I'm talking in general that what's going to happen if they are not attached with your these groups. Okay, yes, so definitely they are attached with your PT. Okay, that means they are attached with your phosphorus, right? Okay, they are attached with your phosphorus. Okay, so if they are attached with phosphorus, so what we have to see that they should be better pi acceptors, right? They should be better pi acceptors. Okay, so if I have to see that there should be better pi acceptors, so what should be right, what should be the order of their pi accepting tendency? Okay, so we have Cl minus, we have hydride minus, we have CH3 minus, and we have OCH3 minus. Okay, so these are your ligands. Okay, so what we have to see that which will accept electrons more easily. Okay, which will accept electrons more easily. So what we can say over here, that chlorine is going to accept more electrons more easily because it is directly attached with this group, right? And which type of effect is more dominating? See, if I draw this particular, right, a ring over here and we have Cl, and if I draw this particular ring over here and we have hydrogen. Okay, if I have CH3 over here and if I have OCH3 over here. Okay, so which type of electronic effect is dominant over here? Yes everyone, can I say minus I effect is dominant? Okay, can I say minus I effect is dominant, right? Okay, so Sunil, what is not right clear to you, you can just let me know in the comment section. अगर आपको हिंदी में चाहिए तो मैं हिंदी में आपको explain कर दूंगी, but please do not spam right in the comment section. This will unnecessarily break right the concentration of students who are actually studying over here. Okay, so this is minus I effect. So predominantly minus I effect will work over here, right? This is this we can say that definitely a kind of inductive effect is only working. Okay, we can see plus hyperconjugation is working over here, right? Please everyone, just concentrate over here. It's okay, right? You don't have to waste your time in this unnecessary things. Okay, so whatever others are doing, just ignore this thing. Right now your time is very precious. You don't have to waste your time in all these things. Okay, is it clear, Rajendra? Okay, is it clear? So just do not waste all your precious time, right? You just concentrate over here what we are trying to study. Okay, just leave it and concentrate over here. Okay, so this is plus hyperconjugation effect. Okay, if I can ignore this stuff, so right, you should also ignore this stuff. There is no need to waste your time. Okay, so this is plus H, that is hyperconjugation effect, and this is plus M, that is mesomeric effect. Okay, so plus H, that is hyperconjugation effect, and over here it's plus M, that is mesomeric effect. Okay, so what we can say that this is mesomeric effect and this is hyperconjugation effect. Okay, this is minus I, and there is no such electronic effect over here, just I effect of your this particular hydrogen. Okay, so what we can say that definitely this will be better pi acceptor. So Cl is going to be a better pi acceptor. Great, because this will pull electrons more easily. Okay, this will pull electrons. One second, just a second people. Okay, great. So let's continue. Okay, so what I was saying, this is Cl, this is hydrogen, this is CH3 and OCH3. Okay, so this is your Cl, so definitely it's going to pull more electrons towards itself, so it's going to be a better pi acceptor, right? So this is Cl, then we have hydrogen. Why this is right, why we have hydrogen? Because see, you can see over here this is having plus H effect, this is having plus M effect. Okay, so plus M is more dominating, so it will give more electron density to this benzene ring rather than taking electron density from this benzene ring. Okay, so we can say that option A is definitely the correct option. Clear everyone? Is it clear? Right, those of you who are right now studying in this session, is it clear? Atanu, Rajendra, is it clear everybody? Then we have Lokesh, okay, Shivangi, all of you, just let me know in the comment section, Shivo, that this is clear or not. Clear everyone? Any doubts? Okay, great. So this is how we can approach the set of questions from TIFR inorganic sections, and these are questions from past 3 years of your examination, right? So if you want me to take more such questions, so I just let me know in the comment section that you want more analysis video of TIFR question papers. Okay, so I'll make sure that I'll come up with some questions to just discuss that what should be your approach of the questions in TIFR examination. Right, it's not a tough examination. Your concept should be strong. See, in JAM point of view, if I give you one more important point which I wanted to just tell you in the starting only, but I forget. Let's discuss over here. If I take JAM into consideration, so in JAM, revision, right? Revision is one pillar of your examination. Test series is one pillar of your examination, and practice is one pillar of your examination. So these are three pillars of your JAM examination. But in TIFR, what I feel that majority of portion is covered by only concepts. Okay, if you're not clear with the practice, if you're not done with a lot of practice, it's okay in TIFR. Okay, this is, trust me, it's okay in TIFR. You don't need much practice of questions. What do you need? You should have good hold of concepts. You should have bunch of concepts with you from a particular chapter. Okay, not from all chapters. You should have bunch of concepts from a particular chapter. Okay, and your concept should be very strong. This is the major difference between TIFR. And do not waste your time in practicing questions from JEE, JAM, CSR Net and GATE for TIFR examination. Okay, this is a humble request to all of you. Do not waste your time from practicing JEE questions, JAM questions, and your net and gate questions for TIFR at least. I'm only saying for TIFR, not for any examination. Okay, do not just interpret the statement. For TIFR, I'm only saying do not waste your time in practicing questions, rather than make your concepts more strong from particular chapters and revise those chapters. Okay, if you feel your theory is not good from those chapters, right, just refer some good reference book. Okay, just refer some good reference book and start studying theory from there. Okay, that is more important. Okay, Rajendra, I'll definitely see your message on WhatsApp. Okay, I'll come up with more questions very soon. Right, this is all about this session. Just take my advice for TIFR. Do not spend a lot of time in practicing questions. Rather than make your concept stronger, pick 5 or 7 chapters and make sure that you are going to revise one chapter daily, right? And you're going to clear your basic things from that chapter and the basic theoretical portion from that chapter. That is more than enough for TIFR examination. Okay, I hope it's clear to all of you, and there is no doubt in this particular thing. Okay, so I'll see you in the next class. Take care everyone. I'll come up with more questions on TIFR. Till then, just keep revising your concepts, right? And I'll see you in the next class. Okay, where should we practice then? From TIFR previous year question papers. Okay, Shivangi, only PYQ question papers are more than enough. Okay, PYQ question papers are more than enough. I don't know what has happened to this new generation now, right? Anyway, okay, I'll come up with physical chemistry next, right? I'll come up with physical chemistry questions from TIFR. Okay, so I'll see you in the next class. Take care everyone. Bye bye. Practice questions from previous years and make your concept stronger. Do not waste time in practicing questions from here and there, right? This won't help you. You just need a good concept from particular chapters. Okay, those concepts are more than enough for your examination. Okay, I'll see you in the next class. Take care everyone. Bye bye.